So we're going to start with review 4. Sketch the solutions to each system of linear equations or inequalities. Solution or solutions. So first of all, we have two lines. I prefer my lines in the form y equals mx plus b. So that's what I'm going to do. I'm going to rearrange it. X plus 2y equals 6. Subtract x on both sides. 2y equals negative x plus 6. Divide both sides by 2, which means that each piece will be divided by 2. So you have a negative 1 in front of this x, so negative 1 over 2 times x, and then plus 6 divided by 2, so plus 3. So let's graph that line. My y-intercept is 3, so I put a dot at 3. Negative 1/2 is my slope. Go down 1 and to the right 2, or up 1 and to the left 1, 2. Let's graph the other one. Also, I'm going to rearrange this one as well. X minus 2y equals negative 2. Subtract x on both sides. Negative 2y is equal to negative x minus 2. We're going to divide both sides by negative 2, which means each piece gets divided by negative 2. Negative 2 over negative 2 is 1. Y equals, all right, the number in front of here is a negative 1. Okay, negative 1 over negative 2. The numbers can't simplify, but the negative over negative is a positive, so that's just positive 1 over 2x. Negative 2 divided by negative 2 is positive 1, so plus 1. Our y-intercept is 1, put a dot at 1, then go up 1 over 2, and it looks like our point of intersection is very obvious. That point of intersection is 2, 2. All right, in number 2, we have some inequalities that we need to graph. Okay, so the nice thing is that we already have this in slope-intercept form, so it's not too difficult to graph. My y-intercept is 3. My slope is in front of that x, which is 1, so up 1 over 1. This is a solid line because there is a line underneath that inequality symbol. Okay, and then our next one is an x equals. So you go to the x-axis, put a dot at negative 1, and it's a line that goes through this dot only, so a vertical line. Is this a solid or dashed line? Well, it's a dashed line because there's no line under our inequality symbol. All right, well, I usually do my shading before I draw the next line, but we'll just do it now. So y is greater than, I'm going to test a point to see which region I should shade for the blue line. And as long as it's not on the line, you can test any point. So I'm going to test 0, 0. So we have 0 is greater than or equal to 0 plus 3. So 0 is greater than or equal to 3. That is not true. 3 is actually greater than 0. So we do not shade in the region where 0, 0 is. We shade in the other region. Okay, and then our vertical line, x is less than, we shade to the left where our negatives are. So your truly shaded region is over here. All right, there are multiple solutions here, not just a point of intersection, so you do not need to put where these intersect because all the shaded region is recognizing all the solutions. Okay, solve each system by substitution. I'm going to do numbers 4 and 6. All right, so I'm going to look for a variable that has a 1 in front of it I only have this y right here, and get it by itself. So I can substitute that expression in for y in the other equation. So I'm going to add 5x to both sides. Y equals 5x minus 1. This is an equivalent expression for y. So when I write my first equation, negative 6x plus 4 times y, instead of writing y, I can actually write the expression 5x minus 1 equals negative 4. So now we'll distribute and solve this equation to get x by itself, plus 20x minus 4. I'm going to add 4 to both sides and combine my like terms, so that's 14x equals 0. Divide both sides by 14. X is 0. Now all I need to do is plug in 0 for x in the rearranged equation, and we'll get out y. So when you plug in 0 for x, you get y equals negative 1. Write your answer as a point, 0, comma, negative 1. Number 6, solve each system by elimination. All right, I have a 7 here, a 4 here, a 7 here, a 4 here. Okay, looks like this might be a special case of some type, but we won't know until we multiply it out. Well, some of us can probably see it, but let's multiply it out just to check. So I want the opposites and the same number in each equation, so I'm going to times this one by 4, and I'm going to times this one by negative 7. So equation 1, the first equation is now 28x plus 28y equals negative 44. And my new second equation is negative 28x minus 28y equals 84. Okay, so now we're going to add the equations. 28x plus negative 28x is 0. 28y plus negative 28y, that's also 0. Negative 44 plus 84 is 40. 0 does not equal 40, therefore there is no solution. And the way that this looks graphically is that you would have parallel lines.